Hi, in this video, I will be discussing the topic Nomenclature of Alcohols. But before we proceed to our discussion regarding nomenclature or naming of alcohols, let us define the term alcohol first. Alcohol is an organic compound whose molecule contains one or more hydroxyl or OH group bonded to a carbon atom. There are two basic systems in naming alcohols. One is common naming of alcohols, and two is IUPAC or IUPAC naming of alcohols. IUPAC stands for International Union of Pure and Applied Chemistry. Now, let us discuss the rules in giving common name to alcohols. 1. Name the alkyl group of the alcohol and add the word alcohol. 2. Use the prefixes normal, iso, sec, neo, and tert, which were also used in giving common name to alkanes. Now, let us have some examples. First, we have here the condensed structural formula CH3, CH2OH. As you can see, there are two carbon atoms in this structural formula. So, the alkyl group is ethyl. The rule states that we have to name the alkyl group and add the word alcohol. So, the corresponding name of this structural formula is ethyl alcohol. Next, we have here the structural formula of propyl alcohol. As you can see in this structural formula, there are three carbon atoms in a straight chain or in a normal position. So, the name of the alkyl group is N or normal propyl. Then add the word alcohol, so the name of this alcohol is propyl alcohol. Next, we have here the structural formula of isopropyl alcohol. Take note that CH3, CH3 indicates an iso position. And since we have three carbon atoms in this structural formula, and so the alkyl group is isopropyl. Then add the word alcohol, so the name of this alcohol is isopropyl alcohol. Next, we have here the structural formula of N-butyl alcohol. This structural formula here has a straight chain of carbon atoms, or it is in a normal or N position. And this has 4 carbon atoms. So, the name of the alkyl group is N or normal butyl. Then add the word alcohol, so the name of this alcohol is N-butyl alcohol. Next, we have here the structural formula of 6-butyl alcohol. As you can see here, the hydroxyl group is bonded to a secondary carbon atom. This carbon atom here is a secondary carbon atom because this carbon atom is bonded to two other carbon atoms. And there are 4 carbon atoms in this structural formula. So, the name of the alkyl group is 6-butyl. Add the word alcohol, so the name of this alcohol is 6-butyl alcohol. Next, we have here the structural formula of isobutyl alcohol. As mentioned earlier, CH3, CH, CH3 indicates an iso position. And since we have 4 carbon atoms in this structural formula, the name of the alkyl group is isobutyl. Then add the word alcohol. So the name of this alcohol is isobutyl alcohol. Next, we have here the structural formula of 3-butyl alcohol. As shown in this structure, the hydroxyl group is bonded to a tertiary carbon atom. This carbon atom here is a tertiary carbon atom because this carbon atom is bonded to 3 other carbon atoms. And since we have 4 carbon atoms in this structural formula, the alkyl group is 3-butyl. Add the word alcohol, and so the name of this alcohol is 3-butyl alcohol. Next, we have here cyclohexyl alcohol. As you can see, this structure is in cyclic form with 6 carbon atoms in the structure. So, the alkyl group is cyclohexyl. Then add the word alcohol. So, the name of the alcohol is cyclohexyl alcohol. Next, we have ethylene glycol. Compounds containing 2 hydroxyl groups on adjacent carbons are often referred to as glycol. And in this structure, there are 2 hydroxyl groups on adjacent carbon atoms. So, the name of this structural formula is ethylene glycol. Next, we have here the structural formula of propylene glycol. As you can see in this structural formula, there are also 2 hydroxyl groups bonded to 2 adjacent carbon atoms. And in this structural formula, there are 3 carbon atoms. So, the name of the structural formula is propylene glycol. Next, we have here the structural formula of glycerol or glycerin. This is an example of a trihydric alcohol or an alcohol with 3 hydroxyl groups. Now, let us discuss the rules in giving IUPAC name to alcohols. They are: 1. Select the longest chain of carbon atom that contains the hydroxyl or OH group as the parent alkane. Number it from the end that gives the hydroxyl group the lower number. In numbering the parent chain, the location of the hydroxyl group takes precedence over the alkyl groups, aryl groups, and halogens. 2. Change the ending of the parent alkane from E to O and use a number to show the location of the OH group. For cyclic alcohols, number begins at the carbon bearing the OH group. This carbon is automatically carbon 1. 3. Name and number substituents and arrange them in alphabetical order. Now, let us discuss some examples. First, we have here the structural formula of ethanol. As you can see, in this case, there are 2 carbon atoms. So, the name of the corresponding alkane is ethane. Drop the E and change to O. So, the name of this alcohol is ethanol. Next, we have here the structural formula of 1-propanol. In this case, this carbon here is carbon 1. This is carbon 2, and this is carbon 3. Since the hydroxyl group is bonded to carbon 1, so we have here 1. And since there are 3 carbon atoms in this structure, the name of the corresponding alkane is propane. Drop the E and change to O. So, the name of this alcohol is 1-propanol. Next, we have here the structural formula of 2-propanol. This structural formula shows that the carbon bearing the hydroxyl group is carbon 2. Since there are 3 carbon atoms in this structural formula, so we have here propanol. The name of this alcohol, therefore, is 2-propanol, with 2 here designating the position of the hydroxyl group. Next, we have here the structural formula of 1-butanol. 1 here indicating the position of the hydroxyl group, and butanol since there are 4 carbon atoms in this structural formula. Next, we have 2-butanol. In this case, we start numbering from the right. So this is carbon 1, carbon 2, carbon 3, carbon 4. At carbon 2, there is a hydroxyl group bonded to it. So that is why we write here 2. And since this alcohol has 4 carbon atoms, hence we have here butanol. So the name of this alcohol is 2-butanol. Take note that in numbering, we have to number the parent chain of carbon atoms in such a way that we will be able to give lower number to the hydroxyl group. Next, we have here the structural formula of 2-methyl-1-propanol. In this case, this is carbon 1, this is carbon 2, and this is carbon 3. Again, the priority is to give lower number to the carbon bearing the hydroxyl group. That is the reason why we started numbering at this site. And since we have here a methyl group bonded to carbon 2, that is why we have here 2-methyl. Then we write 1, designating the position of the hydroxyl group, and propanol because the parent chain here has 3 carbon atoms. So the name of this alcohol is 2-methyl 1-propanol. Next, we have cyclohexanol. In this case, the corresponding cycloalkane is cyclohexane. In IUPAC naming this alcohol, drop the E of the corresponding cycloalkane and change to OL. So, the name of this alcohol is cyclohexanol. Next, we have here the structural formula of 2-methyl 2-propanol. In this case, this is the parent chain of carbon atoms with 3 carbons. And the hydroxyl group is bonded to carbon 2. Moreover, there is also a methyl group bonded to carbon 2. And so, we have here 2-methyl. And we have here 2, designating the position of the hydroxyl group, and propanol, since the parent chain has 3 carbon atoms. So the name of this alcohol is 2-methyl 2-propanol. In the IUPAC system, a compound with 2 hydroxyl groups is named a diol, and the one containing 3 hydroxyl groups as a triol, and so on. In the IUPAC names for diols, triols, and so on, the final E in the name of the parent alkane is retained. For example, in this case, the name of this structural formula is 1,2-ethane-diol. 1,2 here designating the position of the hydroxyl groups, which are bonded to carbon 1 and carbon 2. And since we have 2 carbon atoms in this structural formula, and so we have here ethane. And diol here is given because there are 2 hydroxyl groups in this structural formula. And so the name of this structural formula is 1,2-ethane-diol. Next, we have here the structural formula of 1,2-propane-diol. In this case, this is carbon 1, this is carbon 2, and this is carbon 3. That is why we have here 1,2, because the 2 hydroxyl groups here are bonded to carbon 1 and 2. And since there are 3 carbon atoms in this structure, and so we have here propane, and diol here designating the presence of 2 hydroxyl groups in this structural formula. And lastly, we have here the structural formula of 1,2,3-propane-triol. This structural formula shows 3 carbon atoms with hydroxyl group bonded to each carbon atom. Hence, the name 1,2,3-propane-triol. This is an example of a trihydrate alcohol. That's all. Thank you for watching.